Good morning, all participants. I hope you are doing well. We have completed our 2 day successfully, and all the lectures have been very informative to all of us. Today, the lecture will be on Six Sigma. So, in the meantime, if you want to fill your previous attendance, I think Sai sir is there. You can uh, type in the chat box, and you can ask him for your any of the query, or if you want to fill any previous attendance, if you want to fill. And apart from that, if you have any other query, and then we will begin with our today's lecture. So we have with us Dr. Rajeev Rathi. Sir, can you please switch on your video? Yeah, we have with us Dr. Rajeev Rathi. Dr. Rajeev Rathi is working as an assistant professor in Lovely Professional University. He has achieved his PhD degree from NIT Kurukshetra, and he is very active in the field of Lean and Lean Six Sigma and operational excellence. So in the process of his we can say expertise, he has already published around 65 research papers in international journals, 5 patents, as well as he has been working as a guest editor for many journals, and he is very active member for this Lean Six Sigma field. So I would like that sir will put some light on this area, and will make aware all of us. Yeah, thank you, sir. Dr. Rajiv, sir, to you now.
First of all, very good morning to all of you. And I personally thank Professor Manjeet for inviting me at this event, at this FDP, to deliver in my expert area. And I personally welcome you all guests, all faculties, and the students who have joined this session to share or to listen my views and share the thoughts related to the recent development in the field of continuous improvement. Is my screen visible, Dr. Manjeet?
Yes, sir. It's clearly visible, sir.
Okay. Let's wait for once. Am I audible?
Yes, sir. You're audible, sir.
Yeah. Now, am I audible?
Yes, sir. You're clearly audible.
Yeah. Okay. Actually, I'm setting up my microphones.
No
So,
problem. You can take your time. It's actually just 10 o'clock, so participants are joining actually.
no issue. I think it is quite difficult the participants to be waiting.
They are very patient, sir. We have observed like throughout our session. They are very good,
Okay.
you can say, participant, and all are very good listener.
Okay. And just within few minutes, I'm starting.
Yeah.
Okay. I think I am clearly audible to everybody.
Yes, sir.
Okay. So, guys, I am good morning to everybody again. So, first of all, I introduce myself. I am Dr. Rajeev Rathi, Associate Professor in School of Mechanical Engineering, Lovely Professional University, Punjab. I am a certified Six Sigma expert And today, my topic of concern is related to Lean Six Sigma for manufacturing sustainability, which is more or less is somehow in companion with the theme of your this faculty development program, that is sustainable manufacturing, post COVID sustainable manufacturing. I think so. Am I correct, Dr. Manjeet?
Yes, sir, you are correct, sir.
Yeah. So let's start. So first of all, before starting, guys, I want to give you certain motivation related to this title, Lean Six Sigma for manufacturing sustainability. What is the importance of this in current context? If we see the in the current world, today world, LF companies who are adopting this Lean Six Sigma philosophy into their business, core business, and that are the major giants. If I'm just talking about the major companies who have till implemented and being get benefited and become market leader through this use of Six Sigma and lean concepts together towards a sustainable development goal. 3M, Amazon, and Amazon last year has piloted the Lean Six Sigma in some of their delivery businesses, but now they are decided to launch this program throughout. And I think it is one of the technological giant in world. Boeing, Denso, Wipro, Dell, General Electric, Bank of America, and many other companies are utilizing these concepts to deal with their sustainability and other continuous improvement issues. First of all, if we, as we are going to deal with the basic concepts, I'm not going into much into the higher level. I'm just dealing with some basic concepts related to Lean and Six Sigma, how it works into the industry. So to understand that, first of all, we need to understand what is continuous improvement. And I think everybody who are present here, more or less, are related to mechanical background. Am I correct? More or less are related to more, all are the teaching fraternity here. And in every segment, if I'm talking about the business are classified broadly into two categories. First, manufacturing, and second, service sector. So broadly, we have in the world, we have two sectors in the broader sense, manufacturing and service. And every sector need continuous improvement if they want to sustain. What is the basics of sustainability? What is the base of sustainability is the continuous improvement. If we are not doing continuous improvement in the business, we cannot sustain. We will be out of the market soon. So the base for sustainability is the continuous improvement. Like the three pillars, if I'm talking about the three pillars of the sustainability, that is, yeah, are economic, environmental, and the social pillars. Everybody, everywhere, in every segment, if we do continuous improvement, then can only we sustain our business. We achieve the sustainability, we achieve this growth, we achieve this goal. Sustainability is not only related to, and there is a misleading concepts nowadays traveling. Sustainability is only and only limited to environmental impacts. We can only improve the environment by adopting sustainable practices. This is a myth. Sustainability, all three pillars parallelly we have to achieve. Economic, we have to sustain on economic front. Yeah, obviously on environmental front, and as well as on social. Just wait a while, please. So sorry for the interruption, guys. So
all three pillars we have to achieve in related to in companion to achieve the sustainability, either in manufacturing practices or in services. So we are here talking about manufacturing practices only. We are not going to the service sector side. This FDP theme is related to manufacturing sustainability. So we have to achieve the manufacturing sustainability. So we need to do the continuous improvement. And the today approach, which I'm going to discuss, is based upon the continuous improvement. And that is, if we see what could be the path to cost reduction, what could be the path to cost reduction? First way, we have to cut the services. We have to cut down the services. We have to lay off. We have to reduce the labor. We have to contract work out. We are not going to produce by ourselves. We have to subcontracting the things. Eliminate product features. If we obviously we eliminating the product features, it obviously the cost will be coming down. But this is not the permanent solution to be economic competent. This is a short-term solution. What is the long-term solution to sustain? That is removing the roadblocks so your employee can be able to produce. Assigning the resources to the bottlenecks, whosoever is being there. Maximum use of your capabilities and your plan the capacity planning accordingly. And finally, comply with the customer what exactly they are want, produce that. This is the way to reduce the cost from the economic front to become sustained in the market. First thing, to become sustained in the market, we have to deliver the products of utmost quality with lowest price. This is the basics. So in that lieu, guys, for continuous improvement to sustain, to making the industry, to making the manufacturing system more sustainable, there is a need to adopt a technology which is latest in continuous improvement. And see, I told you earlier, many technological giants are practicing Lean Six Sigma now, and not Lean Six Sigma, Green Lean Six Sigma is now the advanced version which is being adopting by the industries. If just I took a very little few minutes on this quality approaches evolution, how they are being evolved, what is the need further. If I'm talking about when this industrialization happened, so earlier, how many a product a company has manufactured all being absorbed by the community, because demand is very less, customers are very less, because no competitors are there. So whatever you manufactured, that is being absorbed by the market. But later on, when this first industrial revolution starts, competitors are arisen, competitors are coming into the market. There is a customers are starting doing comparison within the product, so they have to think to sustain. So first thing which was adopted during evolution of this industrial arena was inspection. How to sustain into the market, so inspection come into the feed. Whenever more competition was increasing, then statistical process control, how to govern, how to control my process so that I can give a good output. When statistical process control was not enough, and lot of the factors we need to study, which factor is impacting the particular quality indices, the DOE was introduced by Genichi Taguchi. Then Taguchi loss function, then quality management systems. People are working on TQM, which is in generally called as total quality management. And then in 1990, the Six Sigma was introduced. And then now, in nearly 2000, General Electric proposed the concepts of Lean Six Sigma. And further, the research is going on Green Lean Six Sigma, Agile Six Sigma, etc., towards continuous improvement and to become your enterprises more sustainable. So to study or to learn about Lean Six Sigma, it is very essential to understand what exactly the lean is and from what is the roots of the lean. and Six Sigma. So guys, you will be very happy to hear that Lean and Six Sigma both are rooted and derived from mechanical engineering background in manufacturing setup. So Lean management was originally developed by Taichi Ohio, the CEO at that time in Toyota Corporation, who proposed or articulated 7 ways and give the concept of value added and non value added activities. So the and also delivered the main motive of lean manufacturing, that lean management strive for continuous improvement through understanding of customer needs and streamlining processes, reducing cost, improving quality, and imparting through this sustainability into your business. It was originally developed into the Toyota Gigafactory by their CEO Taichi Ohio at Toyota. That was further, those concepts were converted and taken as converted into the lean. Lean means, if in a very single line, if somebody wants to ask to me, or after this lecture somebody asks to you, what do you want to tell, what is lean, let me discuss into the coming this slide. You see there, lean means whatever what is written over here, who articulated 7 waste, removal of the waste from your system. If we remove the waste from the system, we are becoming lean, more agile. You see this picture, what this guy has did, what this guy did, he removed the waste fat from his body and and become and build a very lean body. But is this easy practice to transform this into this? Is this easy practice? No. We have to continuously work for this to achieve these practices into routine work. Then can only lean being achieved. If I'm talking about the lean principles, as was articulated, as was developed by the Toyota Corporation, 5 lean principles they gave. Without, see, one more thing, I'm talking about the researcher prospects also, the researchers who are practicing nowadays, thinking about sustainability. They quoted that without lean thinking, we cannot achieve the sustainability. We cannot achieve. Whatever the lean first principles is, define value. Define value means what is the non value added thing into your system, remove that. Into your product, what is non value added, remove that. That is a waste for you. Then establish the value stream, map the system completely through value stream mapping and all. Is there any waste within your stream map, within your process or not? Understand your flow of the manufacturing, either of the services, because lean concept, this continuous improvement philosophy, lean Six Sigma, is equally applicable to both sectors, services as well as manufacturing. So the lean principles, the third principle is the flow. Then pull, what exactly the customer need, what exactly the customer want, produce that only. And then finally, if we do all these things, we can achieve continuous improvement, and continuous improvement ultimately leads us to sustainable future, sustainability, to sustain my business. Lean principle, focus on what is value to the customer by removing non-value added things, as I discussed, separate non-value added from value added items, make the remaining value added flow smoothly, produce only what customer need. That is called as the pull system. There we have 2 systems, pull and push. So the pull system is that where only the customer need, we have to manufacture that thing. And then finally, if we achieve all the 4 aspects, 4 principles, we ultimately going to be strive towards 5th principle, that is continuous improvement. Let me show you a little video related to lean 4 principles. Just please be. So this is the lean philosophy which is being representing by a short video, how lean can improve your business and ultimately improving the world. Technological companies, manufacturing sectors have proven this. What Toyota is the best example for this. Toyota is now the at the in the if you're talking about in automobile field, it is at the apex level, only and only through lean, only and only by achieving, by doing, adopting the lean philosophy into their core business. And as per the Toyota, what is the lean philosophy? They purely they purely relies on the value, more to value than just cost. Focus on the value of the products, not the cost. Cost is already being standardized if we focus what exactly the value is. Defined it, and they say the value is being defined what exactly the customer want. We have to give that thing in my products. And that is through voice of the customer. Through voice of the customer, this lean philosophy, we get from the customer what exactly they want and we put that thing into the product rather than putting unnecessary facts and find unnecessary things. Just put focus what whether I am putting a thing into my product that adds value, add worth or not. Focus on what is the value to customer. That is the main base philosophy of the lean. Focus on what exactly value to the customer, nothing else. Then can this is the key path to get or to achieve sustainability or sustainable practices in your business. As per the principles, if we are talking about from the lean philosophies, one thing is coming value. And as per the value, the lean concepts categorize the value into two things: value added activities and non value added activities. So guys, you are thinking we're talking about value and how we put the value. So we focus on only value added activities. What are those value added activities? Bring product closer to its functional final form. Value added activities are those who can bring the product into its final form. Value added activities, these are value added activities which are being used to convert the raw material from its beginning to final. Change the form, fit or function. Value added activity means machining process, just for an example. An activity the customer is willing to pay the function of the why, for what a customer is paying, for the functions of any product. A vehicle I am having, how smoothly I can drive it. Its primary function. Primary function is not listening the music. Primary function is to drive smoothly and safely. That is the primary function. And the customer is basically intended to see the whether the primary function is there having worth or not. If we see the non-value added activities, does not contribute to bringing the product to its final form. From the, if I'm just see from conversion of raw material into the final product, doesn't improve the form fit function of the product or service on the first pass through the process, and activity the customer is not willing to pay. And from the lean perspective says remove, reduce these non-value added identification is very difficult of the such non-value added activities in your plant, in your manufacturing unit. If you identify them, try to reduce them. That is waste. What does the lean says? Lean says if anything does not adding value worth to your product or any manufacturing process or any manufacturing system activities that does not add worth to your product is waste for you, is unnecessary increasing the cost of your product. Remove, identify that and remove that. Separate value added from non-value added and try to reduce non-value added activities. So 7 wastes are being identified, are being proposed by the lean concept. And these 7 waste, what does they say? 7 kind of the things who are producing the waste. Any non-value added thing is being considered as waste, and generally 7 wastes are being identified by the researchers of the lean practitioners in mnemonics. To remember them, I give it's an abbreviation, TIMWOOD. What is this TIMWOOD, guys? Transportation, inventory, motion, waiting, overprocessing, overproduction, and defects. TIMWOOD. To learn, to understand these waste. TIMWOOD. 7 waste means how you can say here how the transportation could be waste. Transportation means material handling, transport the materials from one workstation or stores to your shop floor or shop in the shop floor from one workstation to another workstation. And how that you might be thinking, yeah, transportation is the main part. Material handling, without material handling, how we can transport the material from stores to the workstation and from one workstation to another inside the industry? How it could be waste? How it could be waste? Inventory is essential thing. How it could be waste? Without inventory, how we can manufacture? We are out of the stock. Motions. How the motions could be waste? Yeah, waiting might be waste. You can see over processing, overproduction, defects. But how we can justify the transportation and inventory could be waste? People generally thinking, but lean philosophy says transport in material handling, there are might be certain uncertainties. You might be taking longer movements. Your material handling equipments taking much time. Your material handling parts are complex. If they are taking much time than ideal, so that is a waste for you. Remove that waste. There may be certain non-value added activities in your transportation. Remove those. In inventory also, if it is higher, it is a waste. Tied up your money. Transportation, convenience. So it is also considered in the category of lean waste. Inventory also being considered in the category of the lean waste. If it is excess, it is a waste to me. Unnecessary increasing the capital cost. Motion, unnecessary motions around the workstations is also killing your time. It directly leads to increase what? Your cycle time. Waiting, if I am waiting for the parts or for the materials or for the manpower, but they are not coming to my workstation. My workstation is idle for that period of time. Means wastage of my resources. That is purely a waste. Overproduction. Overproduction. Overproduction is also being, if you produced over without knowing the customer demand, it is being stacked in your warehouses, and that is waste. That is waste. And then over processing, if you are doing over processing, that is also a waste. Corrections means defects. If defects are there, what do? You do reworking or rejections. If reworking is there, you do the things again, doing the same thing again, similar thing again. Means your productivity drop by 50% if you are reworking. Ultimately, that is a waste. So lean thinking said, if you want to be sustainable, you have to address all 7 waste. If you are not able to address, you never achieve the goal of sustainability. Getting the point? This is the lean philosophy or the lean concept says. Just an example, a lean thinking, what the lean thinking says. Processing. Process, we have the 3 process in the batch. What the lean concept says. Adopt continuous flow rather than batches. First we process on A, then on B, then on C. Everybody is taking 10 minutes. Other are idle in the meanwhile. A, B and idle. If A is working, B is idle, B is working, C is idle. So lean says why we are not making it continuous, because everybody then being engaged and it is being smoother or faster. A continuous flow. So this is how. Here there were the 30 minutes. Here there was a 12 minutes for the same orders. So this is how we can reduce the cycle time by using lean thinking. Again, a pictorial view of the lean thinking. Because if we are producing without planning, that major impact is there on the WIP, work in process inventory. And if WIP is higher, everything is higher. And what does this, in conclusion, conclusive remarks, lean approach, this philosophy says? Value added is typically only a small percentage of the total time. If from the start to finish, this is the total time. Remove from the shipment, transport, disassemble, then wait, setting up the machines, then we do machining. This is the only my productive time. Then further wait, then further second machining, then further transport, then reinstall it. Means again a machining process. So if I see the value added and non-value added. Non-value added is time is higher. Although non-value added time is also important. Right? The lean concept says that transportation, that thing that does not add value to the work is the non-value added time. But transportation is mandatory. Although it's not add worth to the product. But how we can transport from one workstation to another? By transportation means. So they said that wherever possible, try to decrease that time. This is the lean concept says. You can see the major proportion is non-value added time, and the value added time is only the small proportion. into this segment. Again, a short video, I want to share it with you. Just please see this. See, guys, how this lean philosophy with this the gingerbread houseman manufacturing unit has reduced their time when they will adopt this philosophy from 22 to 4 minutes. And this really happens with Toyota did this, and many other companies did this by adopting the lean philosophy. Now this is all about lean, but in lean Six Sigma, if I'm talking about the continuous improvement, if we really want to be continually improving the things, lean philosophy is not solely do achieve or can achieve the sustainability in my business. For that purpose, I have to align the lean with some sort of the technique who is able that, like lean is only able to attack on the waste, to eliminate the waste. I need a technique which can also, apart from reducing the waste, thinking about the process, how to improve the process. And that technique is Six Sigma. It is the most effective breakthrough strategy. That baseline is only and only to remove all kind of the variations, all variations they are present into the system. All the variations are present into the system. The lean philosophy says. Sorry, the Six Sigma philosophy says all type of process variations. So one, lean is attacking, lean philosophy is purely reducing the waste from the system, and Six Sigma is the counterpart, is removing the variations from the process to get utmost customer satisfaction. So if there is a variation into your process, because if the process variation is there, you reduced all your wastage, but process variation is still existing. Can we achieve sustainability? No. So we need to remove the process variation also, so that your process works smoothly. Your machine, you are removed all the roadblocks. You remove all the roadblocks, remove all the wastage, but your machine, your manufacturing work centers are producing out of the specifications. Does it work? No. So for that purpose, we employ Six Sigma. Before their integration, let's take a brief overlook over the Six Sigma concept or the philosophy. First, we see the success of Six Sigma, how popular it was, how this was the source, this Thomas Pijek book, handbook. The source is there from that book. So Motorola savings of 16 billion USD after incorporating this Six Sigma program. Allied Signals 0.52, General Electric, who has also this GE's derived the concepts of Lean Six Sigma in 2001. And I think the most important influencing unit or industry worldwide in the electric field, Honeywell, Ford, Johnson and Johnson, DuPont, and many other industries claimed a lot of the savings by using the Six Sigma philosophy. Let's see what exactly this Six Sigma is. Organizations generally adopt a lot of the continuous improvement tools. Every organization is thinking here we are going to improve my business. So everybody is utilizing like just-in-time philosophy, total quality management, etc., etc. They everybody is using approach, whether it is a small scale industry, MSME level, or a big corporations. Everybody is hunting for breakthrough improvements. Every tool somehow working well to address a particular problem. But Six Sigma, when till its introduction to today, is ever known for breakthrough improvements because it is a process centered approach. See, everybody I think guys familiar with this man. This is called as the hitman of our country. Why it is called as the hitman? Can anybody let me know among you guys, participants, why Rohit Sharma is called as the hitman? Actually, if you are not interested, I'll let you know. He's called as the hitman because of its consistently hitting capability of the sixes. Consistently, if he committed to hit a six, he definitely do it. Rarely he fails to hit a six. It means the process capability of this person is very higher in hitting a six. Similar way, the Six Sigma capability is very consistently hitting the six. In the same fashion, if I'm talking about Six Sigma, if I'm talking about the Six Sigma, is a process improvement methodology by making the process so robust that chances of error get be eliminated. Likewise, Rohit Sharma, six hitting capability. Although there is no correlation, but just both are benchmark in their own field. That's why I just try to make certain connection between them. How Six Sigma was evolved and where are the roots? It is guys not a rocketing science. The Six Sigma rooted from a statistical words. It is rooted in statistics and derived from the word sigma. Derived from the word sigma. And sigma, I think everybody knows, is known as standard deviation. But many of you know, guys, just this is what is standard deviation. You just have heard the word. Very few, except a qualified statistician, very few know the real meaning of standard deviation. What exactly it is? If I'm talking about industries, they are constantly practicing statistical applications to check the performances only. So what does the standard deviation says from which the sigma arrived? The symbol of this is a Greek symbol represented by sigma, this. And sigma denotes standard deviation. What is the standard deviation? And it is an indicator of the process or the degree of variation in a setup process. An indicator which tells us how much variation is there in the setup process. You may say, sir, dear, this can only be, we can find out if we find out the mean can also let us know what is the deviation into the process. I will give the answer of that also. It determines the spread into data by how much a particular data set is deviating from a particular target value. Suppose you are a manufacturer of a shaft of 100 mm in diameter. So target, what is the target value? 100 mm diameter shaft. Every time we do not get that 100 mm due to several X factors, noise factors present into the system. Sometimes I got 99.99, sometimes I got 10.01, 001, 002, 3, 4, SE 99.9897. Every time, very few times I directly hit on the target value 100 mm. That's why the tolerance is being provided, tolerance limits, so that within, if the part is lies within the limits, that can be acceptable. And if I want to see the spread into the data, how much data is being spread, to study the process, how my process is performing, I use this word, this thought, this concept, sigma, standard deviation. How are we are standardly deviate from the target value, that the mean value that was 100 mm in diameter, which I want to manufacture. So it determines the spread into the data set. Then can I decide what exactly is happening. Sigma marks the horizontal distance on horizontal axis from the mean value. So standard deviation is a measure of how far an individual measurement, a particular shaft diameter, for an example, tend to be from the mean value of the data set, tend to be from the mean value. Mean value is an indicator what is your mean, and what is the spread into the data, that how much you are deviating from the mean. That really tells us your process. So when we are studying business statistics, when we study my manufactured item, I see their geometric perfection, I need to study standard deviation. ठीक है जी, I am agree with the mean. My mean is, say, I'm not, my mean of the shaft, so 100 shafts is 100.01 mm. 100.01 mm. But how much is the spread? What is the standard deviation level? How much my pieces are deviating from that mean value? It means something, if they are deviating heavily, it means there is some disturbance into the system that needs to be relooked. This is that this standard deviation tells us. This example, company A, it's not, I think might be visible to you. Their salary, company A, all 4 employee wages are tightly bunched around the average. Here 19 to 20, average might be 20, and they are bunched around 20. Company B, their salary packages are being widely dispersed along the mean value. So it means this is the low standard deviation. How perfect the processes we can see, how close to the central tendency. Here we can see the process is highly dispersed. It means they are heavily deviated from the mean value. They are heavily deviated. If the process is heavily deviated from the mean value, the chances of error might be higher. If we do not look on the process instantly, it may be soon out of the limits. It may be soon out of your upper and lower specification limits. And if a process is out of the limit, how we can achieve sustainability? If my machine is not producing good, how can I am talking about sustainable practices? These are the sustainable practices. These things can enforce sustainable practices if we are doing perfectly. If my process in well in control, well inside the control limits. If my mean is not shifting, then can I only talk about sustainable practices. If my process is not in my control, then how can I talking about, how can I thinking even about sustainability in my manufacturing unit? Whatever I can do, I can never achieve sustainable practices. I can never impart sustainability. I can never reduce emissions. I can never be economic. If I'm not economic, if I'm not environmental friendly, how can I do the goodwill of the society as an industry? So if I am not able to compete on all the three matrices of sustainability, how can my industry be sustainable? This is the big question. How much advanced techniques you are adopting? How much advanced machine you are being putting in your in-house to manufacture? But if your process is out of control, how you can be sustainable? This is a very big question to think. Standard deviation. See, if the mean height is this mean height is this, and if we see the longer height is what is the standard deviation? 147 mm above the mean height. See, 147 mm to the both is in the acceptable limit. So using standard deviation, we have no a standard way of knowing what is normal, what is abnormal. If something lies between standard deviation, so that seems to be normal, but beyond that, that is abnormal practice. This is how the standard deviation defined. And from this, why I'm stressing much on this, because Six Sigma is derived from the standard deviation concept. Process concept, how much the process is closely performing. We can see here the difference between Six Sigma and Three Sigma capability. Here the spread is higher. Here the spread is higher in Three Sigma. The graph is more extending towards the control limits. It may be out of the control also. But if we see the Six Sigma capability, the process variation decreases and the graph is coming towards the central limit, the central tendency, your mean value. You are performing better. As the variation decreases, probability of the defect decreases for a given specification limit. So ultimately, the capability increases. The capability increases. As the process capability increases, obviously, you can sustain it. You will become sustainable into your business. If your machining is become sustainable, producing the good parts every time. So what is sustainability? Sustain the things. And first of all, we have to correct the process. How to correct the process? When we study the process. When we study different matrices of Six Sigma. If we achieve the Six Sigma, it's only the Three Sigma process, 99.9.66 values within the specification limits. Means a robust process, we can say. In the Six Sigma, it is more skewed rather than Three Sigma. Only how many defectives? 3.4 per million opportunities will be nearly 4 defects. In a simpler language, I'm talking, I producing 1 million parts, only 4 would be the defect opportunities. If we really work on the Six Sigma level. And how to find out this DPM or defect per million opportunities? Number of defects in a sample upon total number of the defects opportunities, and it is being normalized to 1 million. That's in this way we can identify, we can calculate defects per million opportunities, a very key indicator of this Six Sigma. A process is believed to be Six Sigma practice when one can fit 6 standard deviation between process mean and nearest specification limits. See, process mean and nearest specification limits. If we can fit all these sigmas into these, if only we can fit 5 sigma level, if we can only fit 3 sigma level we can achieve, if we can only fit 2 sigma level. How guys we can fit these things? on the depending on the value of the sigma. If the value of the sigma is higher, so this distance increases. This distance will increase. If this distance will increase, so only less sigmas will be fitting between nearest specification limit and the mean value. If less sigma will be fitting, the curve shape will be looking like this, more wider curve. If more wider curve, the data points will be falling more away from the mean value. If they are falling away from the mean value, your process is unstable. Try to relook on the process, rethink on the process. The power of Six Sigma lies in ability to see. This is the statistical concept till we discuss about Six Sigma capability, what is sigma and all kind of the things. But now what Six Sigma exactly, and how, what is the way of working with Six Sigma to improve the process. In Six Sigma, all the problems are called as defect. Whether it is a problem your machine is not working, not only whether the you produce the defective items, no, that is a defect definitely, but every problem is considered as a defect. This is the beauty of this Six Sigma practice. Every problem, whether your machine is not working, either your we can say the capacity of your system is poor, capacity rate, utilization rates are poor, either your material handling is not proper, so everything is considered as a defect. And then we form what approach they are being using. How does Six Sigma solve the problem? First, define the practical problem. What is exactly the practical problem? The parts are being rejected. This is my practical problem. So define that completely using certain phases in define and measure phase based upon the MECH approach: define, measure, analyze, improve, and control. Then convert that practical problem by gathering the data and facts into statistical problem. Then further find out the statistical solution, and then statistical solution is being converted into a practical solution to deal with the problems. This is how the Six Sigma deal to solve the problems. Suppose just an example, the practical problem is pass rate of the technical exam students was declining very fastly. What could be the statistic? Now we have to convert it into statistical problem. So there may be a problem with the exam section. All possible statistical problems we are going to convert into them. Place of training, how often skills are used, elapsed time since training. These are some statistical problem. These are the key. There may be problem in exam section. There may be problem in the training of the students. There may be inexperienced teachers are teaching them. The time since training, huge time is there since training. They were lapsed completely. Statistical solutions. 3 sections of exam are the highest trouble sports. If some exam section is the critical problem coming out after certain analysis, so statistical solution, 3 exam sections troubling highest sports. Experience is the most significant factor in passing. If experience is there, so they will deliver good to the students. Practical solution, focus training on 3 areas for inexperienced technicians. This is just an example. Industries are using very advanced tools and techniques to solve the Six Sigma problems in a Six Sigma way. Just if we see the scope of this Six Sigma, how better we can do into the world. This is at the 3 Sigma level, 99%. If we are working on the 99%, and we are from 99% is in our current world in India is considered as a very, very good practice. If we are doing 99% perfect, what does the Six Sigma concept says then? If at 99%, 20,000 lost articles of mail per hour, if we achieve this Six Sigma, only 7 articles of mail will be lost per hour. 50 minutes of unsafe drinking water each day. So here 1 minute of unsafe drinking water per 7 months will be delivered, will be supplied to your houses. 5,000 incorrect surgical operations per week at 99% capability rate. 1.7 incorrect surgical operations per week. How drastic change will that if we achieve this level, 6 sigma level, from 3.8 to 6? I'm comparing 99 to 99.996%. And some of the industries are, as we just observe, are operating on 1 or 2 sigma level. Majority of the Indian is small and medium sector industries. Too short or long landing at major airports each day at this level. And if we achieve the 6 sigma, 1 short or long landing at in every 5 years. These are the research facts, these are not quoted by me. Cost of quality levels comparative to the 6 sigma. Defect level 3.5. So cost of quality means how you are spending to maintain the quality, less than 10%. So you are world class. Your organization is the world class. Highly sustainable. 233, 5 sigma level, 233. Cost of quality is 10 to 15%. Poor quality, reworks, rejections. If we are non-competitive, we see at this level, industry average, nearly 3-4 sigma level, 66,807 defect rate, parts per million opportunities, 20 to 30% of the cost of quality. It's an average, and you are non-competitive. You are investing more than on your cost of poor quality. So how we can be sustainable, how an industry can be sustainable fully if they are operating at this level? At least at 5 sigma level, if you cannot achieve this 6, then can you only be sustainable. And our main thought is Lean 6 sigma. Although guys, a lot of the things to talk, but with limit of the time, I'm concluding soon with this. It's a combination of 2 distinct approach. As you all know what is Lean and what is 6 sigma. These 2 wonderful approaches to achieve the sustainable practices, LSS. This popular new approach process to improve the process combine best of both frameworks by reducing variations and waste. See, 6 sigma reduce the variation and Lean reduce the waste. It's for focusing on the need of the customer to become more sustainable. Lean 6 sigma draw its powers from using tools in framework that identify customer needs and all. Lean management, major focus on the reduction of the waste. 7 waste cover, I think, all the processes of the industry, as we discussed. And 6 sigma seeks to improve the quality by eliminating variation. If variation from the process is being eliminated, obviously quality will be improved. Once I remove the waste, here I am removing the waste, I am become more environmental friendly, and I am eliminating the variation. I am making my process more robust. So I am taking the step towards process improvement. So it was evolved in 2001 by General Electric and have applications, as I told you guys, in services also, such as manufacturing, to hey, finance, healthcare, IT, military, everywhere the Lean Six Sigma having its applications. Still, in the previous decade, if I'm talking about, the Indian industries are not much familiar about this practice, but nowadays they are also being adopting these practices, because today, this decade, current decade 21 to 30 is the decade of imparting sustainability into the business. And without adopting continuous improvement strategies, we can never incorporate, never achieve the goal of ultimate sustainability. When we talking about Six Sigma, it is all around reduction variations, reducing. So Lean part is doing the thing faster, but Six Sigma is the doing the things right. If we combine these two, doing things faster and right, obviously we achieve a good sustainable practice. A framework to integrate Lean in Six Sigma. Processes, say machining process 1, machine process 2, machine process 3, machining process 4. So Six Sigma deal with the process improvement. how to improve the process, how to make the process perfect. Lean work in between the process, how to remove the known, because non value added activities, where the non value added activities in between the process value added activities. So lean purely work upon removing roadblocks of non value added activities. This is how a lean Six Sigma way can be used. This is a very unique framework to adopt lean Six Sigma practice in any of your business, either service or manufacturing is concerned. So combined process solving. So if we see under the nutshell of Lean Six Sigma, we use Kanban, Kaizen, statistical process control, JIT, full system, visual management, 5S, 7S also, value stream mapping, ANOVA, design for Six Sigma, design of experiments, MSA, measurement system analysis, hypothesis testing, root cause analysis, and many more other tools we do use combinedly to solve or to implement Lean plus Six Sigma in industries. So guys, this is all about Lean Six Sigma, and I have many things to talk about, but with the limitation of the time, I have to also talk about the DMEC, how to implement Lean Six Sigma. I want to quote an example, a case study. With a case study, I want to show how we can be sustainable. But with the limiting of the time, I have to wind up it very quickly. Let's see the latest trends in the latest research, what is going on in the sustainability field. If we see in the Journal of the Cleaner Production, all the articles are of 2021, connecting lean and green with sustainability towards a conceptual model. So without lean, we cannot imagine the sustainability. Triple bottom line. And analyzing and prioritizing Lean Six Sigma enablers with environmental facets. How a case of Indian MSME. Connecting, this is, I think, oh, sorry, being repeated. Integrating sustainable production value measurement. Model based upon Lean and Six Sigma in Industry 4.0 context. IEEE transactions on engineering management. Journal of Cleaner Production, everybody is aware about the reputation of these journals. So see how what is the trend today is there. Production planning and control, another apex journal in mechanical field. Sustainable setup stream mapping, a systematic approach to lean sustainable manufacturing. You can see the trend. You see, this is again the latest article in a top-notch journal. Sustainable setup, a value stream mapping tool, means a lean tool, we can say, system approach to lean sustainable manufacturing. Integrating lean and agile practices for achieving global sustainability goals in Indian manufacturing industries. So without means, say, without these achieving these practices, we cannot think for sustainable manufacturing. Exploring an investigation of Green Lean Six Sigma adoption barriers for manufacturing sustainability. Again, IEEE transactions on engineering management, top-notch journal. Technological forecasting and social change, again a very top quality journal. And see again the Journal of Cleaner Production, connecting lean and green with sustainability towards a conceptual model. So all, if we see the top, the from this is the perspective of the top-notch journals. I collected the data from the top-notch journals only. So you see in 21 itself, how many lean and Six Sigma related articles are there to improve, to achieve sustainable practices in manufacturing context. A lot of the articles there in service context, other context also, but specifically for manufacturing background. So how important the presence of these two approaches together to become competitive in the current world, current domain. So guys, this is I think all, but how to get started, a lot of the things are also untouched. I just a few only, just taking more 5 minutes to let you know after these recent trends, how to start with this. So only the Lean Six Sigma is adopted through this MECH methodology. LSS projects are executed with MECH. Define, measure, analyze, improve, and control is the full form of this MECH methodology, where we do improvement area, find critical, screen critical, purpose, solution, controlled implementations, and all. Although a very dedicated lecture is needing to discuss this MECH and the applications which are related to these such articles, we can say. But with the limiting of the time, I have to take the question answer also of you guys. So this is all from my side, and I am summing up with the latest trends. If you have any question to ask, anything in your mind, in your brain child, so you may please welcome. Thank you very much.
Yeah, thank you, Dr. Rajeev. A very insightful and a great lecture, particularly on the current trend. Yesterday, we also discussed about lean continuous improvement, and we tried to define the role of continuous improvement in sustainability. But today, you made it very clear that sustainability cannot be achieved without continuous improvement. And
Yes,
after
exactly.
that, yeah, and after that, you made it very clearly that how lean impact in a manufacturing industry to reduce the waste, whereas what is the role of Six Sigma. So the model was very clear, and the lecture is very informative that how manufacturing industry can achieve the sustainability, because both lean and Six Sigma, as you discussed, is very important. And apart from that, the last few slides shows the current trend in top-notch journals also. So very informative session. I would like to thanks. And now it's all the participants, you are welcome to ask any question from our expert now.
Yeah, thank you very much, Doctor. Thank you very much.
Sir. So any question? Yeah, Rolam, someone has raised his hand, so you can unmute yourself. Ask to unmute. Let me.
Yeah, please unmute yourself here. And
I think you can unmute yourself right now.
Yeah, sir, thank you for your very informative talk, Rajeev sir. It was quite inspiring to hear about the Six Sigma concept. You made it very interesting through very good illustrations. I have two questions.
please.
On the discussion we had. Sir, we discussed sustainability as a three-pillared structure, which is based on economy, environment, and society. So of this, which do you feel is a more important pillar in current context?
Here, if I think some echo is there.
I'm sorry, if I should repeat that.
No, I got your question, but
echo
is coming. Just I have to reconnect. Hello. Wait, please.
We can hear you, sir.
Hope I am audible.
No, you are audible. Some echo is coming back to me.
Okay, sir. I'm trying to control it. Enable it.
Hello. Yes. Yeah, dear. What? Hello. Am I audible?
Yeah, you are audible, sir.
Please turn off your mic. Somebody is not.
Yes, sir. I have turned off.
See, you ask a very good question, dear, whether which pillar is important. So, in my opinion, not in my opinion, what the research community says, like environmental pillar, economic, and societal. Every pillar is important. If we neglect any of the pillar, we cannot achieve sustainable practice. If you are excluding the environmental pillar, obviously emissions will be rising. If you are eliminating economic pillar, my balance sheet will be disturbing. If I remove the social pillar, I'm neglecting that. Again, what we are doing, the practices ultimately is doing for the betterment of the society. So every pillar having its key importance in sustainable practices. That's why all the three pillars are to be there to achieve continuously. Either you are doing a simple practice of making your machining process sustainable, you have to look for all three things. Whether you are adopting a life cycle assessment, so what you are doing there, you are doing all three analysis in life cycle assessment of a machining process I'm talking about. You doing all life cycle assessment, every three processes, economic indicators you will talking about, economic, environmental, as well as your societal impacts of your life cycle assessment. So I think everything is important. Is this clear? Clear?
Yes, sir. Yes, sir. Thank you, sir.
Yeah.
Sir, one more point I just had in
Please,
mind.
please.
Yeah,
Yeah.
sir. It is about the role of innovation.
Mhm.
Innovation
Mhm.
in lean manufacturing. So, what way we will encourage innovations in lean manufacturing? There are certain systems which are standard systems which are not open to innovation. Like a standard manufacturing system where there is a very less flexibility for incorporating path-breaking changes.
Yeah.
So how Lean Six Sigma takes account of innovation as a good practice.
See, this is again a very good question from your side. See, what does the Lean Six Sigma says? What is the philosophy of Lean Six Sigma? Doesn't need a new system, doesn't prompt any industry to buy new technology, new machines, new manpower, establish a new center of excellence. This is the beauty of this approach. This concept says we have to prove or improve existing system with these technologies by removing value, separating value adding and non value adding activities, or by improving the same process. Lean Six Sigma always prompt to do or achieve continuous improvement in the existing system. Although it is always welcomed if you are adopting a new technology, but Lean Six Sigma, the first line of attack is this: we have to improve existing system by this concept. The concept was molded or developed, evolved. The frameworks are developed in such a way they are capable to deal with the existing system. Okay.
Yes, because we all often refer to continuous improvement in the Lean Sigma approach. So presently, what we see that earlier we had a transistor radio. So now we have switched on to advanced technology. So how migration from a new way of thinking can be incorporated into our concept, or is this alien to Lean Sigma? Yeah, are they two different things which you cannot bring into?
There's nothing is different. The thing you are for transition you are talking about, that is a disruption into the technology. One is being destroyed, another thing is being coming up.
Yeah,
this is called as the disruption technology. Right. So if I'm talking about Lean Six Sigma, if we see when the Six Sigma journey was started in 1986 by the Motorola corporations, or Lean Six Sigma journey started early in 2000, it is only limited to applications in the manufacturing assembly lines. Right. But now if I'm talking with today concept in this 21st century, in this decade 21 to 30, if I see the Six Sigma and Lean are being supported by new models and the frameworks. Now sustainability is being added to this. Green is adding into this. Green Lean Six Sigma nowadays the people are proposing. Lean Six Sigma in Industry 4.0 era, or Six Sigma or Lean Six Sigma 4.0 is coming up with new tools and techniques of IoT based systems and all. So this is the advancement is also being there. This is not stagnant. If the Lean Six Sigma is also stagnant, we do not modify the Lean Six Sigma model with time. So this is not being longer as a continuous improvement strategy. This can never being supports in the current coming time being act as a sustainability improvement or sustainable practices. Some other approaches will replace it, like TQM is being replaced by Lean Six Sigma.
Thank you, sir. Thank you.
Yeah. Any other question? I think you got your answer very clearly. Any other question, participant? No, I don't think so. So still, if you have any question, you can text me on my WhatsApp. I will ask from the expert. And
Yeah, no issue.
yeah, and sir already clearly explained that the purpose of lean is not to replace the existing technology. This is what we should take care with us, because when we are studying about some lean concept, then lean is a continuous improvement. At the same time, we do not want to replace our existing system, and we don't want to do drastical change. Okay, only a continuous improvement with existing facilities. So very nice lecture. With this, I would like to say thanks to Dr. Rajeev, and I would like to make one announcement that next lecture will be at 1 o'clock. So exactly 1 p.m. our expert will be here. So he requested to prepone the lecture. So everyone, please be available at 1 p.m. Today. So thank you, Dr. Rajeev. Very nice lecture. Thank you, sir.
Thank you so much. Thanks a lot. Thank you everybody for listening me a lot.